Good afternoon and welcome to today's webinar, CHP Power Webinar. My name is Melissa Herreria and I am with Courtney Strong, Inc. We are contractors under the Economic Development Growth Extension Contract to NYSERDA. Thank you for joining us today at your lunch hour. I am here with Matt Lockwood and Geeta Subramoni from ERS. And on the phone is Devetta Thatcher of NYSERDA, all available to answer questions. We have muted all of the participants or everyone who's on the phone as an attendee, and we are taking questions at the end of the webinar. There is a questions tab where you can type in your question, or you can raise your hand and we will unmute you at the end of the webinar to ask your question. The webinar is being recorded, and we will make that available to everyone who has registered, as well as posted on CourtneyStrong.com. I will also email it to everyone. Thank you, and I will pass it on to Matt.
Hi, good afternoon, everybody. My name is Matthew Lockwood. I'm a project engineer for ERS. Energy and Resource Solutions is an engineering firm. We have offices down here in New York City and up in Troy, New York. And we are contracted by NYSERDA to provide outreach services and technical assistance to customers thinking about CHP through their CHP Acceleration Program. So today we're going to talk a little bit about what CHP Combined Heat and Power Technology is, why and how and when it can be a useful tool to help your facility promote resiliency and reduce on-utility costs, and talk a little bit about resources that are available through NYSERDA's CHP Acceleration Program to help with an installation. Finally, we're going to wrap up just going briefly over what my role and ERS's role is with this program and how we can help you. So first of all, we're going to talk about what CHP is. As I said, CHP stands for Combined Heat and Power. It's often also called cogeneration. And it's a technology whereby we use one fuel source. In the case of NYSERDA's programs, that would be natural gas, but that could be diesel, fuel oil, what have you. Use one fuel source to produce the co-products, electrical power and heat, thermal output. Now you can think of CHP as a power plant. Con Edison here in New York City actually has the largest cogeneration system in the world. It has 5 power plants to provide power to customers on Manhattan Island, and at the same time the excess heat produced by the power process is converted to provide steam heat to over 1,800 buildings here on the island. So CHP systems that we are incenting through the acceleration program, think of them as a power plant, but as a power plant that is unique to your building. It's essentially an engine. This is a graphic of average CHP system. Think of it as a power plant and a generator plus. It uses natural gas to both produce electricity to help take care of some of the electrical loads in your facility, and it also produces heat. And as distinct from a generator, in a generator you think you spend a lot of money purchasing this asset and maintaining it, running a lot of tests, and then you hope that you never ever have to turn it on. CHP system, on the other hand, you want to use it as close to 100% of the time as possible whenever there's a simultaneous need for both heat and electricity in your building. So in a typical configuration, a building would power its electrical needs by purchasing power off the grid, in this case from Con Edison. And then it would also have a boiler down in some sort of mechanical space that would burn a fuel, natural gas, fuel oil number 2 maybe, and that would produce domestic hot water and also perhaps steam to do space heating as well. Now a CHP system would slot right alongside those existing systems. One of the nice parts of CHP installations is that they don't require significant rework to any of your electrical or thermal infrastructure in your facility. So slot it right alongside, would use natural gas, go into this engine, produce electricity, so supplement electricity produced off the grid, and at the same time would add some heat into the hot water space heating loop on this building. So this has a number of advantages. It can provide 24/7 backup power, which we'll go into much more detail on later, but also allow you to purchase much less electricity from the grid. We have the term we call spark spread. That's the difference in cost per unit gas as compared to per unit electrical power. Typically, gas is much cheaper than electricity. So if you can produce your own power from natural gas, you can save significantly on utility bills. We can see anywhere from 20% reduction in utility costs with a successful CHP installation, which is pretty incredible. Building really has a lot of options in terms of how they set up their CHP installation and exactly how they're using their heat output. This is an example of one building that was incented by NYSERDA and how they've chosen to set up their system. Here we've got a natural gas supply running two 75 kilowatt combined heat and power systems. The electrical load is providing 24/7 power, and extended grid outage would also provide power for any critical systems in the facility. And the heat output is being run into a hot water loop to provide thermal load for domestic hot water, space heating, and laundry. I want to highlight this is just how one system decided to set up their CHP system. I've also seen cases where a cogeneration system was used to heat in a pool, to power an absorption chiller to provide for cool air during the summer months. You can also use the heat for appropriate manufacturing processes as well. So once again, CHP, think of it as a power plant. It's not really a very new technology. It's something that we're all familiar with. As an automobile, we use one fuel source, gasoline. Now, one fuel source through an engine produces not only mechanical power, but electrical power to help control the car, provide for climate control, lights, and also provide heat for the cabin as well. And we see the same thing. This is a 787 jet engine. We have jet fuel that is not only producing thrust to keep the plane in the air, but also providing electricity for avionics control, navigation, lights, cabin heating, and even in-flight entertainment. So a lot of uses out of just one fuel source. Here we see that CHP is actually starting to become much more prevalent in the United States as well. This is a couple of months out of date provided by ICF International, and we've got about 4,100 CHP projects here, providing 81.8 megawatts of total power. I want to highlight that you can see there's a huge concentration right here in the Northeast New York State specifically area, and that's for a number of reasons. First off, NYSERDA's CHP incentives are actually among the most generous in the nation. They're extremely motivated to install CHP here on the ground. Also, we have some of the most economically favorable situations for a CHP installation. We've relatively high electrical utility costs and relatively low natural gas costs. So we've got a very large spark spread. Anytime that's happening, facilities can realize some significant economic advantages from installing a CHP system. And at a larger scale, not only do CHP systems provide for increased resiliency for facilities and some utility cost savings, but it's great for the environment as well. As you can see here, these 4,100 CHP installations have eliminated 241 million tons of CO2 each year, which is equivalent of reducing 40 power plants. They also have saved 1.8 quadrillion units of fuel each year. Now, that's about 2% of total U.S. energy consumption per year, which is a very large fraction. It's going to be only growing from here. So why is CHP good for your building? This right here, some of you may recognize, it's a somewhat iconic photo from Hurricane Sandy here in New York City. This is actually the Bellevue Hospital. They had experienced some flooding in the lower section of the hospital, which actually knocked out fuel pumps that were providing diesel fuel to the generators that were supposed to keep the Bellevue online. So the National Guard had to form a bucket brigade bringing fuel oil 13 stories up to the generator to try to keep the facility online. But after 2 days, the entire facility had to be evacuated. So one of the primary benefits of CHP is it really helps facilities stay online during extended grid outages. The natural gas, which runs all of the NYSERDA-incented CHP systems, is an uninterruptible power source. So unlike electricity from the grid or diesel fuel, where you're limited by your on-site storage and then the ability of a truck to get in to bring you more, outside of a major earthquake, natural gas will flow 24/7 and be able to keep your facility online. All of the systems that are incented by NYSERDA CHP acceleration system can both run in island mode and are what is called black start capable. So island mode is exactly what we're talking about. It's a CHP system being able to run when the rest of the grid is down to provide power to the facility to keep critical systems online. Black start capable means that it can actually start up even when there's no power coming in from the rest of the grid. So in addition to resiliency as well, it's also going to save significant money on utility bills, and it helps save the environment as well. As I said, you can think of combined heat and power cogeneration plants as sort of a generator plus. Through here, we're just sort of comparing the advantages of both technology. From a system performance level, backup generators are an expensive asset that are never really utilized, whereas a CHP system, it's designed and maintained to run 24/7, so it's got extremely high performance reliability, and it's also helping provide some significant savings every minute of the day. From a fuel supply perspective, natural gas is not typically impacted by severe weather, as I said, whereas backup generators, limited by on-site storage, and as I said, in the event of extended grid outage or severe weather, it's very difficult to get additional diesel fuel on site. CHP systems are already running all the time, so they can flicker-free transition from grid connection to island mode. They don't need to start up because they're already up and going. Whereas a backup generator, there's sometimes some significant lag time that may impact some critical system performance. That could be on the order of seconds, on the order of tens of minutes to get power back online. CHP systems provide both electricity and thermal use during extended grid outage, so you can still have space heating and domestic hot water, very important during inclement months, whereas a backup generator only can provide electrical power. And also CHP systems typically have a better emission standard than a backup generator, which usually runs on diesel fuel. So as I said, on an individual level, a facility can benefit from the increased resiliency and cost savings of cogeneration installation. But on a system-wide level, it's much greater for the environment as well. Here I've got a theoretical building. Doesn't look like much, I know, but we've got the building will use 30 units of electricity and 45 units of steam. Now, in a traditional generation system, I would purchase my electricity off the grid. The power plant has, its own inefficiencies when it comes to producing power, and then I have to get the power, which will lead to some transmission losses. So the overall efficiency of traditional power generation systems getting all the way to my facility is about 31%. So in order to satisfy my demand for 30 units of electricity, I'll need to burn, or the system will need to burn, 98 units of fuel entirely. At the same time, 45 units of steam, as I said, I would produce that on site in a mechanical room and a boiler. Those typically about 80% efficient, so I need 56 units of fuel to produce my 45 units of steam. So all told, we're using 154 units of fuel to produce my 75 units of electricity and steam all told, which leads to a 49% overall efficiency. Now with the CHP system, on the other hand, I'm going to put in some fuel, and at the same time I'm producing both electricity and thermal needs. And CHP systems, we typically see an overall efficiency of about 75%. So 100 units of fuel to fuel my 75% need. So on a system-wide level, we're using significantly less fuel to meet the same demand. Just a quick note on terminology here. Most of our CHP systems are sized according by their electrical output, but we want to caution you to think of electricity as a happy byproduct of this system. One of the most important parts about preserving the economics of a CHP system is to have an appropriately sized unit. Typically, the thermal need of most facilities that we see is a little bit less than the electrical need, and so you'd want to be what's called thermal following. You want to size according to the thermal needs and then get as much electricity out as you can at the same time. So, will CHP be a good fit for your facility? The answer is yes, if. If your building has a significant annual need for both electricity and thermal needs, then CHP might be a good solution. The building should have some centralized way to get the thermal load to end uses. So typically we see that as a centralized domestic hot water system or a space heating system. All of the systems that are incented by NYSERDA's CHP acceleration program do run on natural gas. So natural gas must be available at your facility, and it must have a significant or sufficient quantity to run the CHP system. And part of our role here at ERS is we are a free resource. We're an experienced engineering firm, and we can help you with some of these questions. We can help determine if you have the characteristics that would make for a successful CHP installation. The keys to CHP success: you want to make sure that system is sized well. The closer you can come to using all of the heat and electrical output of a CHP system, the better the economics. Typically, we see systems that are successful having a minimum runtime of 6,000 hours per year. And to translate into day-to-day thinking, your CHP system should run full bore about 16 hours a day, 16 and a half hours a day at minimum to have a successful installation. Second, think of this as a car in my earlier example. Cars, can run for 80,000 miles or they can run for 300,000 miles, and the biggest difference there is how well you keep up with the maintenance. These CHP systems are, many of them are essentially internal combustion engines. Just like an internal combustion engine, they're going to need engine block maintenance, oil swap outs, all that kind of good stuff. All of the CHP systems incented by NYSERDA's program do carry a maintenance requirement from the vendors. Finally, you want to make sure that you're balancing your needs at all times. You want to make sure that the system is sized that can provide emergency power for your system in case of an extended grid outage, that you are able to make use of the thermal output of the CHP system to get the economics, and that you have some use for the electricity that you're producing. So who else has CHP? There's a quick list here. As I said, there are 4,100 installations across the states, and here in New York we have a very high concentration of them. If you have any interest or you are from a specific industry, I'd be happy to have you contact me. I'd be happy to give you some case studies specific to your industry. So let's talk a little bit about NYSERDA's CHP acceleration program. This is a program that targets the small to medium-sized customers, so that's 50 kW to 1.3 megawatts in size. And this is a catalog-based system where there are a number of pre-qualified CHP. These are basically systems that have been vetted by the state of New York and NYSERDA to meet minimum engineering and business longevity standards. There's a fixed incentive for each one of these systems. The vendor applies for the incentive. The incentive goes to the vendor directly with the understanding that that would be taken off of your final cost. These incentives are actually extremely generous. They range from $1,200 to $1,800 per kilowatt. As I said, those are among the best in the nation. And there's a $1.5 million cap per project under the acceleration program. If you do happen to have a larger facility that's looking at a CHP installation of above 1.3 megawatts, that would fall under NYSERDA's CHP performance program, and I'd be happy to connect you with some resources available for that. As I said, NYSERDA, this is a program that's run on a catalog-based system. You can find this with a quick Google search, and in it, you're going to find several hundred CHP systems here with a little bit of a sort of a quick description of the overall size of the CHP system, its weight, some facility needs, and most importantly, you also see these NYSERDA incentives right here. These are listed in the catalog. You can see that the incentives for the downstate area are slightly greater than the upstate area. There are also 2 bonus incentives available as well under the CHP Acceleration Program. These are both 10% bonuses. First off, there's this 10% bonus for facilities that would qualify as critical infrastructure as defined by either excuse me, with a $1.5 million incentive cap per project. There are 2 separate 10% bonuses available for this. First, if you are a facility that represents critical infrastructure, it would typically be hospitals, nursing homes, food distribution centers, command posts, things along those lines. The critical infrastructure as defined by the Red Cross or Office of Emergency Management, you are eligible for a 10% bonus. Most of the time, if you are one of these facilities, you'd know if you'd qualified as critical infrastructure. But if you have any questions about that, we can definitely connect you with either the Red Cross or OEM to determine if you are critical infrastructure or if you can petition to be labeled as critical infrastructure. And second, there is a 10% bonus for sites that are down here in the downstate area that fall within Con Edison CHP target zones. And if you have any questions about that, I'd be happy to take a look and tell you which one you may fall into. The NYSERDA CHP system has some streamlined CHP sizing guidelines. If you are a facility that's a multifamily housing building, nursing home, hospital, or hotel, and you size according to these conservative guidelines established by NYSERDA from past projects, then you can actually have a streamlined application. There certainly would be some reasons to go above and beyond these guidelines if you have higher than expected thermal needs, or if you're a facility that operates in an industrial zone outside of these guidelines, you can certainly still apply for incentives, and we'd encourage you to do so. You just have to undergo a feasibility study as part of your application. And there are some resources available to help you with the cost of that as well. So how much do CHP installations actually cost? And the answer is, it depends. As you can see here, I've got on the left system sized, and on the third column, total cost. You can see that roughly total cost tracks according to the system size as you'd expect, but there can be some differences. You can see this 300 kilowatt unit costs $1.8 million total. There's also a 600 kilowatt unit that costs $1.8 million total. And you might ask why that is. And the answer is that part of the equation is the overall system size. The other part of the equation is the actual specifics of your facility and on-site. If there is very easy installation, as you can see, without a lot of additional costs, percentage covered by the incentives can be over 50%. And if it's a more challenging site with a few more infrastructure changes that need to happen, then it can be a little bit more expensive. NYSERDA's CHP Acceleration Program incentives are designed to cover between 30 to 50% of the total installation cost on average. I haven't really seen any that have gone less than 30%. As you can see in a really stellar example where CHP's kind of a no-brainer and it's an easy installation, those incentives can be beyond generous, well over half of the project costs. Here's an example of the kind of cost savings that some CHP installers have actually seen as a result of their installation. And once again, if you're from a particular industry or sector, I'd be happy to connect you with case studies specific to your sector. In most cases, we see that the CHP systems incented by the program after incentives typically see a payback between 4 and 7 years. So that's an internal rate of return of 25% or around there, 20 to 25%. And in some exceptional cases, that can go as low as 3 years. So finally, I'd like to wrap up today talking a little bit about what ERS's role is here in this whole process. We are a free service. We're paid by NYSERDA to help you. We can provide education and technical resources to help you determine if CHP would be a successful technology for use in your facility. We provide end-to-end support, and we can help connect you with further resources, either with vendors or with programs that can help you ameliorate the costs of feasibility studies. The most important thing that I'd like to highlight is that we're a free resource. We've already been paid for, and we don't have any financial skin in the game. So we're here to be your advocate and answer any questions that we have for you. We also, as I said, provide some high-level engineering analysis to determine if CHP would be a good fit for your facility, and program vendors are also available to answer some more specific engineering questions. So next steps, if you are interested in CHP, learning a little bit more about it or learning a little bit more about your facility, you can contact NYSERDA's EDGE team, which does outreach contracting for them. You can contact ERS or me specifically, or you could attend a CHP Expo if you're here in the New York area. The next one coming up is Friday, November 20th at 9 a.m. This is a CHP breakfast and tour at the Roosevelt Landings. Starts at 9 a.m. There'll be breakfast, some presentations, and a tour of an actual working CHP facility. If you have any questions, you can contact me. My name is Matthew Lockwood. My email address, mlockwood@ersinc.com, and my phone number is right there. In summary, CHP is excellent technology in the right application. It can help save a good amount of money on utility bills. It increases resiliency to keep your facility online during an extended grid outages. NYSERDA's CHP acceleration program offers extremely generous incentives covering between 30 to 50% of the total product costs. And if you have any questions, please flag them here, or you can contact me. I'd be happy to talk to you one-on-one and explore whether or not CHP would be a good fit for you. Thank you very much.
Thank you, Matt. Looks like we might have some questions coming in. But actually, I do have one specific question as I read through these. I get a lot of people who ask about maintenance with CHP systems. And just wondering if you could talk to that a little bit. Like, how is the maintenance? Is that something that is done by the installer? How does that exactly work?
So there's a number of different ways you can approach maintenance. Either have train an in-house team to perform the maintenance, or have an existing relationship with the vendor who can provide some outside maintenance. All of the CHP systems that are incented by the program are required to offer you a maintenance contract, and that's at least a minimum of 5 years. I'm not entirely sure on what the costs are. Those can really vary on a vendor-by-vendor or relationship-by-relationship basis. But if you have specific questions about that, please reach out to me, and I'll make sure to connect you with someone who can give you more precise information. I do want to highlight that maintenance isn't really an option for CHP. CHP system could last for 5 years, just enough to pay it back, or it could last for 30 years, and the big difference maker is going to be how well you keep up with maintenance.
Thank you. So we did have a question come in. What is the breakdown of the 75% efficiency of a CHP system between electric output and heat output? Does it matter how that heat component is used, space heating, DHW, or process loads?
Thank you for the question, Robert. I unfortunately don't have a lot of specific information here for you, though I'd be happy to look into a little bit more depth and get back in touch with you. My understanding is that there's not a significant difference in heat recovery between DHW or space heating or anything along those lines. The biggest limiter in terms of process is that you don't get extremely high temperature steam out of a CHP system. So using it for a very high temperature manufacturing process can be challenging and significantly impact the efficiency of the heat reclamation. But as I said, I'd be happy to look into that with a little more detail on the breakdown between the two and get back to you if that would be something you'd like.
So this seems like a pretty good question here. A recommendation to so they're talking about laundries and how there's an excessive amount of lint which can clog up pumps and heat exchangers. Is there a solution to that specific issue?
Biggest solution that I've seen there is regular maintenance accompanying with good filtration. Obviously, if there's lint getting stuck in the heat exchanger, that's going to drive your efficiency down very, very quickly. So keep on top of, keep making sure that the filters are replaced regularly.
Will the program in the future help or assist in the purchase of CHP units that are smaller than 50 kilowatts?
Thanks again, Robert, and the answer is almost definitely. Gita,
close
you
to
comment on this?
Yes, hi all, this is Gita Subramoni from ERS. So there has been talk of expanding the program to accommodate smaller than 50 kW sizes for CHP systems. This is something that the program will revisit next year. So it's likely that might happen, but we'll have to wait until next year until there are approvals from the Public Service Commission to approve program changes.
Thanks, Gita. Lee Parker asks, you gave us an example of electric use and steam, but later a slide said that eligible systems must have hot water distribution systems. Please clarify.
Thanks, Lee. I really appreciate you picking up on that. It is not necessary that a system necessarily only have a hot water distribution system. The most important aspect of a successful CHP installation we typically see in a lot of these facilities is finding some way to make use of the thermal output of a CHP system. And typically that only really happens in facilities that have some sort of centralized distribution mechanism. So that makes a lot of sense when there is a hot water loop. It could be space heating as well. Anything that you can do to use as much of that thermal output as possible will make for a successful installation. Did you have something to add to that, Gita?
I guess the other thing to say is that with space heating, you would only need space heating during the winter months when it's colder. But in order to maximize the economic benefit of your CHP system, you need to be using it year-round, where there's a coincident demand for heat as well as electricity. And so having it tied to your domestic hot water loop, domestic hot water is used year-round. So in relation to that, it makes the CHP system more economical when you can use that heat output year-round.
Great. Thank you very much.
We did get some questions on whether or not this presentation will be available, and the answer is yes. I typically will take the recording and post it up along with a PDF of the presentation on CourtneyStrong.com. We've got some more questions coming in.
Sure.
So we have a question on sizing in regards to, I guess, loads, summer loads versus winter loads being lower in the summer and larger in the winter.
Okay, so this is a question from Mr. Ramesh. Thank you very much. He's asking about a facility that has very little need for space heating or DHW during the summer, but a very high thermal requirement during the winter. That might be for something, for example, something like a factory or a school. And the answer is that typically we see successful CHP installations are at facilities that are able to, as I said, run for on average 16 to 18 hours plus per day. So if you have a facility that would only be able to really make full use of a CHP system, 5 months out of the year, that's probably not going to be enough thermal need to make for a successful CHP installation. Now the answer for that is to size your system according to what's called your base thermal load. So that'd be sizing a CHP system such that you're able to make use of the thermal output of the CHP system at all times of the year. So sizing it according to your summer needs. During the summer, I do see a lot of facilities that use, here in New York, for example, that use the CHP output, thermal output, to run an absorption chiller to provide for air conditioning during the summer as well.
Thank you. Do fuel cell systems with heat recovery qualify for the NYSERDA CHP incentive?
There is a fuel cell incentive program through NYSERDA, I believe. I don't know very much about that, but I could certainly connect you with NYSERDA's EDGE contractors who would be much more knowledgeable. All of the systems that are incented by NYSERDA's CHP acceleration program and performance program are not fuel cells. So the technology specifically for the acceleration program are microturbines and internal combustion engines. Certainly, fuel cell heat recovery can be a very successful technology. It's just not incented by this particular program.
Now, there's a question from Peyton Vang on the acceptance rate to get NYSERDA incentives. What is the acceptance rate? I'm guessing that part of it is just a discussion on the application process for the incentive.
Hi all, this is Geeta Subramoni from ERS again. In terms of acceptance rates, the program works when vendors are actually responsible for filling in the application paperwork and submitting that to NYSERDA. NYSERDA then reviews it and approves it. If it falls within the sizing guidelines specified by the catalog, there's a fast-track review. For other building uses, or if you want to go above the sizing limits set by the catalog, there might be some additional feasibility studies required by NYSERDA to approve it. In terms of acceptance rate, if the vendor and the customer follow the program rules and install the CHP systems within the recommended time frame, then the incentive is accepted and transmitted to the vendor. The vendor, when they charge the customer for the price of the equipment and labor, but minus the NYSERDA incentive. So the vendor is technically on the hook for making sure the incentive paperwork is correct, because they are the ones that receive the incentive and transmit that. They knock that off the top of the price to the customer. Thank you.
Thank you very much, Geeta.
Is there a list of qualified vendors available on the NYSERDA website?
Absolutely, there is. If you check the NYSERDA, the site for NYSERDA's CHP acceleration program or the catalog, you'll see a full list of all of the participating vendors. I believe there are 14.
14, and I think up until recently, and now there are, I believe, 13.
Okay, 13 qualifying program vendors. I did see a few questions as well on some economics being adversely impacted by utility standby rates. I don't have a lot of specific information for that at hand. However, if you want to reach out to me, either via phone call or email, I'd be happy to look into that in a little more detail and get back to you.
And I do want to thank everyone for your interaction on this webinar. It's really appreciated. As I mentioned, it has been recorded and it will be posted. Give me, 24 hours to send it over to you. Contact information is still on the screen for Matt Lockwood, and I will also send the contact information over an email. Thank you very much for spending your lunch hour with us, and we really appreciate it. Have a great day, and we look forward to hearing about your CHP projects in the future. Thank you.